Gavin Gee here from UltimateReloader.com. I'm here at the 2023 SHOT Show at the Annealing Made Perfect booth with Alex Findlay. Thank you for joining us, Alex.
Pleasure.
It's always great to talk with you, and one of the things I enjoyed this year, and I did a video on this book, was to go through this book and just really understand how your company came to be, a little bit about you personally. It's a father-son team that's going on. I mean, there's a lot here that I think people would enjoy reading the book to learn about how you guys created this successful company, to learn about all of the people in the industry that you've gotten connected with and have learned from. A lot of the same people that I rub shoulders with. And ultimately, in the end, you have two successful products, the AMP Mark II, Aztec technology, that's on the one side, and then the AMP Press on the other side, sort of validating the output.
Absolutely, that's what it does.
Yeah, so when you think about the story, if you were going to tell someone the story of how this came to be, face to face, where do you start?
Well, first, the reason I wrote the book in the first place was because everyone kept asking me, how did you guys come up with this idea? So I thought, well, so many people are asking, they want to know, so I'll write a book about it. It took a lot of work to write that book,
yes.
But I think it's worth doing it. Mm-hmm. The company actually started way back in 2012. That's when we incorporated the company. We didn't have anything but a vague idea that we'd like to do something with annealing.
Right.
Matt is an engineer. He used to work at Air New Zealand in those days, and so he's a very keen engineer. I've always been a reloader and a shooter. And so we decided to put our heads together and see what we could come up with. At the time, annealing was considered to be a dark art.
Right.
Some guys thought they were heroic annealers and knew everything what there was to know about it, but the majority of people didn't anneal at all because it was just too complex and too difficult. Yep. Just to back up a little bit, about the reason why people want to anneal or should anneal in the first place is brass work hardens as it gets reloaded and sized and shot. Every time you do that cycle, the brass gets harder and harder and harder. What that means is that when you resize that case, the brass springs back out of the die. So you're not getting accurate resizing, accurate in terms of conforming to the die itself.
Right.
And in the past, if you don't anneal, people have had to adjust their dies to oversize it so it springs back out of the die to the correct position.
That was one of the more interesting things I picked up from the book, was when you talk about neck tension and brass hardness. Now you might think the brass is harder, so it's going to squeeze the bullet harder, but in reality, when it gets sized, if it's harder, it springs back more, which lowers neck tension with the bullet. It's almost counterintuitive.
Yeah, people always, once they start annealing, they have to adjust their sizing die. If they're using a bushing die, which most of our customers will be doing that, they need a bushing probably at least 1 thou, maybe even 2 thou larger, because the case neck simply doesn't need as much sizing as it used to without annealing.
Right.
So that works great. So that's why people actually want or need to anneal. But as I said, back in those days, most people didn't anneal. They just fired 5 or 10 shots out of the case, threw it away, bought a new lot of virgin brass. Yep. Well, that's a lot of a waste of brass, and also you're not getting as much accuracy as you could be getting if you were annealing.
Right.
So that's the basic motivation behind annealing in the first place.
Mm-hmm. And then there are also longevity aspects to it as well, right? With stretching and separations and
absolutely.
And all that kind of stuff.
with annealed brass, when you size it, you can get incredibly accurate dimensions. So a lot of people without that will tend to size maybe 3 thou shoulder bump, for example. With ours, we can easily repeat 1 thou shoulder bump every time. So you're not stressing the brass nearly as much. Yep. You should anneal every time, and that way, every time you size that case, you're getting exactly the same result.
Right, because ultimately with the rifle, it's all about doing the exact same thing every time.
Repetition.
Interior ballistics, exterior ballistics, right? BC variation and all that. The shooter, hopefully the weather, right? If you can control those things. So how did you know that you wanted to anneal? Had you heard of annealing through someone?
The first time I heard of annealing was through a gunsmith friend of mine who made a beautiful custom rifle for me. It's in the book. Yep. There's photographs of that rifle.
That the 257 Weatherby?
257 Weatherby, 300 Win Mag and 4.6, switch barrel gun. Right. And he made this beautiful gun for me, and then so I did all the reloading and working up loads for those cartridges, which was a lot of fun. But ultimately, about 6 months later, he said, "Alex, you've got to learn how to anneal." And I had no idea what he was talking about. And anyway, so I went round to his place. He got a big gas torch out, a bucket of water, and turned my cases into cherry red. And I thought, oh no. So I ended up throwing those cases away, but it sowed a seed. It made me sort of start researching with Matt. We started researching what is this annealing all about.
Yeah.
And once we realised the significance of it and how it was being done, we thought, well, we can probably do better than that with the existing techniques of using a blowtorch and probably temper-lack or sitting in the dark and waiting for it to glow.
Which is a thermally sensitive paint, essentially.
Yeah, it's a very hit and miss method. And even with using temper-lack, if people were using that, there was a great debate about how you even should use that.
Sure.
It was crazy, you know. So we thought, well, there's got to be a more scientific way of making this thing happen.
Yep. And then you thought, how can we explore this domain? Because and when did you guys think induction?
Very early in the piece. We played around a little bit with gas, and we were looking obviously at the internet and seeing what else is available.
Sure.
And there were lots of, that was in the days when rotary tables and automatic feeds, you know, case feeds were happening onto blowtorches.
Yep.
And that was about as sophisticated as it got. But some guys were on various different forums, some guys were talking about making induction annealers.
Okay.
And we thought, well, that sounds, we actually had an induction cooktop at home. Magic piece of equipment.
Sure.
So we thought, well, that's so much more controllable and precise, like it's digital.
Yeah.
And so we thought that's much more, if we're going to do an annealer, it's got to be induction. And so that's when the trail began back in 2012. We decided, yes, let's do this. So we incorporated the company, got the web domain, and went from there. 4 years later of intense R&D, we came up with our first product.
And remind me, what type of engineering did Matt study and work in?
Matt's he's a tool maker by trade.
Okay.
He's a precision engineer.
Okay.
He's not an electrical engineer though, so neither of us had any electrical expertise at all.
That's why I asked that question. This is sort of a whole different adventure, right?
So we had no idea how to do it, but we know how to ask the right people who do know how to do it.
Yes.
So we went to an electronics design company in Auckland in New Zealand, and we got started. We made our first little rudimentary, or they made it for us, but the first little rudimentary induction system with a copper coil, and of course the copper coil kept on burning out every couple of anneals, but it was the first generation of heat, if you like, and so we decided we couldn't go any further with that particular company. But one of the consultants that they were using in the magnetic side of things, which is the induction, was a professor at Auckland University of Technology, and he actually asked us if we would like to work with them to further the project, because he could use it as a project for his students. It worked out great. So they did all the original development of the circuit boards and the inductors and the whole process. All of that's in the book, and it was a fraught process.
Yeah, I enjoyed reading about the blow-ups. This is some of the things that people don't realize. To develop a product like this, you have to really push the boundaries of what's possible.
Most people who are designing, if you go to most electrical design companies, they're using low voltage stuff like phones and and sort of 12 volt or even lower. Not many people specialize in high voltage circuitry. And ours, our original circuitry, were doing 380 volts, so it's high voltage. And when you're in the prototype stage, things go wrong. And when they go wrong, there's a very loud bang and another day's work to try and reconstitute that board, which is now blown up. We didn't have the luxury or the money to have multiple circuit boards to rely on. So we had this one circuit board that blew up, they would rebuild it, blow up again, and we were trying to track down what's causing the blow-ups. But Matt and I just got shell-shocked. We were so jumpy. It's like a shell-shocked veteran almost. If you're in a car park and someone slams the door, we jump because we were...
Did you have hearing protection?
No.
You never know when it's going to happen.
You never know when it's going to happen. But when it happens, it's very spectacular.
Yeah.
So,
Did you track down what it was?
Oh, yeah. There was what was happening was that the inductor, it's an emitter of electromagnetic radiation. And so that radiation was getting into the circuit and causing the blow-ups. That's one of the reasons. So what we had to do was isolate the inductor in an aluminium box, so it's a completely separate component, so that the radiation from that can't get out and contaminate the circuit board, causing blow-ups. There's lots of reasons why you can get blowups, but that was the number one reason.
Interesting.
Yeah. So that took probably a year of work just to get
Yep.
that part sorted out.
And then you guys were looking at, do you go with a variable gap or a fixed gap and geometry? And
Yeah, because there were so many variables. What we found is if we had an inductor, incidentally, just so I can explain it, is a circuit of, or unless you're using a copper coil, which is a different system, we're using a thing called ferrites, or a ferrite core, and it's wound with a product called Litz wire, which is copper wire with multiple strands. There's, again, photographs and explanations all in the book.
Yeah, right.
And when the electrical charge, like 380 volts, goes through that wire, it turns the ferrite core into an electromagnet, essentially.
Okay.
If you put a gap in that circuitry, the magnetic flux flows from one pole to the other. And when a case is inserted in that flux, that's what causes the heat. So, but what we found was the wider the gap, the less power you got.
Okay.
Because it was diluting it every time we made it wider. So
Makes sense.
if we had a gap that suited a 50 BMG,
Yep.
a 223 just about didn't get warm. Right. So there was a real conundrum for us. We were using fairly low power at that stage too. So we had to do huge amounts of research to get the inductor itself correct. Once we got it right, it's fantastic. But boy, that took a lot of work.
This is the difference between garage engineering and truly working with world-class engineers.
Yeah,
you know,
exactly.
you can build something that's fine, but to truly optimize a design, especially with the versatility that you needed out of the system, you have to really, really understand what's happening physically and what's happening electrically, and be able to manipulate the parameters, measure the results.
Well, the important thing was that we set the goals in the first place. We realised from looking at what was happening on the internet, lots of guys were able to produce heat with an inductor.
Yep.
That's not the challenge. The challenge is controlling that heat, so it gives you the exact correct annealing. And that's a huge step away from just making something that makes things hot. We were determined that if we were going to bring something like this to market, it had to be plug and play for the user. They had to have no guesswork. They weren't going to use Templac. They weren't going to sit in the dark.
Right.
They were going to put a number into that machine, and it was going to deliver the correct result.
Right.
And that's the hard part, because what that requires is not just electronics. That involves metallurgy. You've got to understand what's happening to that brass in order to get it to anneal correctly.
Because you're not going to see it physically. The appearance of the brass can be very misleading.
Oh, absolutely.
Right. It can look perfectly annealed, you know, the heat discoloration and all that. Yeah. But then internally, you didn't do anything, or you did the wrong thing, whatever.
So what we did, we initially consulted with professional metallurgists. There was a funny thing in those days, all the guys online, all the forum guys, they all said they knew a metallurgist, or they knew a friend of a metallurgist,
right.
And they're saying that 750 degrees Fahrenheit is the correct temperature to anneal. There was all this misinformation out there that was, but we believed it, because who were we? We had no idea ourselves until we started talking to metallurgists.
Right.
And we had a consultant metallurgist that I thought I took some annealed cases over to him to get him to do some hardness testing, only to find we weren't even close. We weren't doing any annealing at all. We were just making it hot.
Right.
So we then, through a process of, after we did enough testing with him, we decided, hey, we've got a big volume of stuff we've got to do here. We've got a lot of data we've got to generate. So we bought our own micro Vickers hardness testing equipment, which was a big investment. In those days, we had no money. Yep. But it was a big investment, but we figured that's the only way we're going to get a product that will perform as we want it to perform for our customers.
Yep. The micro Vickers hardness testing is really interesting, because a Rockwell hardness tester applies a force and it makes a dimple, and the size of the dimple is proportional to, you know, the hardness. With a micro Vickers hardness testing system, you're doing that on a very small scale. You guys sectioned the cases and can look at all of the different areas of the case, whether it be the web or the shoulder or the neck, right? And to be able to pinpoint the hardness of the brass and to focus on the area that makes the most difference, and then to actually get a reliable, scientifically valid result out of that.
Exactly.
I haven't seen anyone else do that. You guys are hardcore. You're going all the way into this, right?
It's the only way. I mean, what we're annealing, obviously with the head of the case, I should just grab a case. So When you're annealing, what you're wanting to anneal is the neck, the shoulder, and 5 millimeters of the body. Right, so that's going to mean when you size that case, the neck is going to have no spring back, so it's going to size accurately, and the shoulder is going to have very little spring back, so it's going to shoulder bump very accurately as well. So that's what you're trying to do. You're not trying to heat anything down here.
Right.
Now, there was a huge amount of misinformation out there about how you control migration of heat down the case.
Okay.
And some guys even put 450-degree Temperac down here as a go, no-go, that if that goes black, you've got to throw that case away. That's all nonsense. The reality is that when you get this hot enough with what's called flash annealing, which is in a matter of a couple of seconds you get the job done, while the rest of the case is way too hot to touch, it's not nearly hot enough to be causing annealing.
Right.
So down here it doesn't get hot at all.
Which you discovered early on. It can get really, really hot, and you think you're doing something to it, and then in reality, it's doing nothing.
Nothing. I mean, do you have to quench it in a bucket of water? No. It's a silly idea, and it just gets your cases wet. There's no need to do it. So that was, you know, where we had the targets of what we wanted to achieve, and it was a huge leap forward. Once we got our own testing equipment, we could start processing stuff in volume, and we could do our own tests to say, right, well, it's literally like working up a load. What I would do is I'd start with a low temperature and work up and keep on testing every time until I got to the Goldilocks zone, where we're getting, it's actually, just to expand on the Vickers hardness testing regime, 200 is about as high as you can get, a bit higher, but not much higher than 200 for brass, and that is spring hard. That's very, very hard.
Hardness number you're saying?
It's a hardness number which the Vickers machine will spit out for you. On the other end of the scale, 60 to 65 is dead soft. You can crush it with your fingers. Right. So in between, what we're wanting in here is about 95 to 100 on the Vickers scale, and coincidentally, or not coincidentally at all, that's exactly what Virgin Lapua is, that's exactly what Virgin Peterson, Alpha, any of the top brass does the same thing. So we thought if that's what they do, that's what we got to do too. So that's the target hardness.
Gotcha. Okay, so going back to the story, you guys are working on the Mark I machine, essentially, the first platform.
We didn't know it was a Mark I in those days.
Right, yeah. the first iteration, and at some point there's an epiphany, right? Where you're doing a bunch of work with people's cases and having to produce what we call these codes, right? You've got the machine, you've got the pilot, which centers and positions the case, and then you've got the code that you type into the machine, and if you set that all up, you're going to get the right result. But that involved shipping brass to you and a bunch of lab work.
Well, to go back a little bit from that, we made a target. While we were making progress, we were getting no closer to actually producing a saleable machine. There were other things we had to do as well, apart from just make it hot and get the metallurgy right. We have to pass codes of compliance for electrical safety. That's a biggie. Now, any guy in his garage isn't going to do that. So, but for us, selling it to the public, we've got to know that no one's going to electrocute themselves, no one's going to burn the house down. And so there's a hugely rigorous regime you have to go through in order to get compliance for that. It's a very expensive and slow regime you've got to do. You've got to give them multiple units.
In multiple markets too, right?
Yes, absolutely.
Right.
There's no such thing as an international standard.
Right.
And so they test to all these standards, and tens and tens of thousands of dollars later, you had to make changes to it to make it pass. And you've also, not only that, you've got to pass what's called FCC regulations, which is electromagnetic radiation. So you've got to make sure you're not going to stop some guy's pacemaker.
Or someone's airplane taking,
Exactly. So there's all these considerations that the guy in the garage doesn't worry about any of that, but we do. So when people get our annealer, it's passed all that certification. It's completely safe.
Yep.
So that was one of the other things. But when we got to, by 2015, we came to our first SHOT Show. And that was a huge event for us. We brought a prototype along with us, which was not even a Mark II, it was a Mark Zero. And it was rudimentary, but Accurate Shooter posted it on their upcoming SHOT Show new products.
Right.
And we had a booth not nearly as nice as this booth, and we just got deluged with guys who wanted to know about this annealing system.
Yeah.
It didn't have buttons. It had a pot dial to change the. It didn't put much power out. It got a 223 kind of hot, but people got the idea of what we were trying to do. And it was actually Brian Litz when he visited. He said, look, you guys really need to ask guys to send you samples of brass so you can expand your library. Because at that stage we were just working with what we had on hand, 308, 223. One of my friends shot a 300 Wisdom, so we had whatever they had, but we didn't have anywhere near everything covered. So when we started asking people to send us samples, we got inundated with samples, which meant I was tied up in the lab all day doing what I now love doing. And that generated a huge amount of data. So the next SHOT Show, 2016, we actually had the Mark I ready to present. And fun enough, we still had a couple of blow-up issues even then. So when we bought those ones to SHOT Show, we bought I think 3 units. One got sent to London in the UK by mistake with the airlines. But the ones we did do, they worked for the show. We nursed them through, and then one of them that we were going to give to Brian Litz to test blew up while he was before he got there.
Oh wow!
So it was stressful, but we were so close to a real product at that stage. So by April 2016, we had the last of the blow-up problems sorted out. We had the programming sorted out as well, and so we sold our first 45 units in April 2000. In February 2016. Then we decided, right, this is no longer a home business. We can't run this out of the garage anymore. So we rented industrial space in Pukekohe, which is the town just south of Auckland where we live.
Gotcha.
And that's when we started full production at that stage.
So where I was going with all of this lab work and the data is, let's talk about Aztec a little bit. So Aztec is magical. Right.
It is. It really is. But the motivation for Aztec started with all these samples that we were getting, and Matt actually came up with. We were sitting down having tossing ideas around, and he said, "Dad, look, we've got to make this machine a smart annealer, right? Because everyone isn't going to send us samples all the time, and we had enough experience to know that even if you're shooting the same brand of brass on the same cartridge, lot to lot, there's enough variation that you can't rely on a published number. Yes, the only way to do it is if you actually test every single lot of every single brand. Now that's impossible to do. So Matt identified this and said, we've got to make this a smart annealer. So we did months and months of work based on the inductance graphs or the inductance patterns that the machine produces. We got nowhere. We simply couldn't find out we couldn't correlate inductance with annealing. Until we made a mistake one day. And we were testing some Norma 308 brass and getting the graphs that we always got, and by accident we put a Winchester 308 case in, and all of a sudden we got this massive spike in the graph that shouldn't be there. And Matt said, being an engineer, he said, that's a yield point. And so that was the aha moment, that was eureka. We're onto something here. And what we identified was that basically, and we did in more cases the same way, we deliberately tried to over anneal them, and we got the same spike every time. And so this was a datum point that we could work off. And so from that we were able to then reverse engineer, if you like, and say, well, if that's the point where the case fails, where the case neck melts, if we go backwards, can we work out where the correct annealing point is? And that was the start of about 6 months of my time in the lab every day, gathering data with different cartridges, everything from 17 Hornet through to 50, well not 50 BMG in those days because we didn't have the Mark II, but up to 338 lapel, Shaytac, all of that stuff. And every cartridge had a different point, and not only a different melt point, but a different formula that was required to convert the melt point into annealing accurately. So that was a massive amount of work that we did in the lab. Unfortunately, we had all these samples hanging on the wall from what other customers had sent us. So we were able to generate a massive amount of data, which was just invaluable.
So this was my biggest mystery about the AMP Mark II. I got it, and I was running analyze passes, right? So what Aztec is it generates the code for your brass, right? That lot, if you've turned your necks, whatever it is, it's going to figure out exactly what the right annealing code is. And I thought to myself, I'd put it in there and I would analyze it and see it, starting to melt. And I thought, they've got some magic technology here, because somehow there's this electromagnetic flux happening. They're able to detect something, engineer this code out of this. Like how is this possible? And then when I read the book and saw your lab experiment and your mistake and all that, it all clicked for me. But see, I'm a mechanical engineer. The whole electrical world to me is very much a mystery. But what I learned, using the Mark II, is that annealing is a very precision-oriented activity. And there are a lot of different variables. But if you can control those variables and get a super consistent result, which requires it to be computer controlled, right? There's a whole lot of things happening there. The result is perfect annealing, right? And perfect annealing does affect the longevity, and it very much affects the reloading process. Yeah. We talked about consistent neck tension, very consistent shoulder bump, right? And things like shoulder bump actually slightly affect the interior ballistics, just like bullet seating depth does. If you've got a smaller chamber, higher pressures. If you've got a larger chamber, lower pressures, right? More or less. So Aztec was essentially a software development exercise during the Mark I timeframe, is that correct?
Yeah, that's exactly right. So when we finally got it to a finished product, it was just in time for SHOT Show, I think 2018, when we demonstrated Aztec for the first time here at SHOT Show. People could not believe what they were seeing. Right. We burned a whole heap of brass because people, show me that again. They couldn't believe it. Yeah. And it was so deadly accurate that it just dumbfounded people. So we then made that so it was a software download. People could go onto our website, buy the software, do the download, and their Mark I now had Aztec capability. Yep. It's interesting, of the thousands of Mark Is that we sold, probably about 70% of them now have the Aztec download. Gotcha. So it's just a no-brainer. If you own one of those machines, you should do that.
So let's briefly cover then Mark II, because Mark II has Aztec built in.
Yes, it does. But the other main thing, there were several big improvements but from the Mark I to the Mark II. Yep. First one was 50 BMG capability. Yep. We had the 50 BMG Association of America, I think it was, crying out to us, we can't anneal our cases with an induction annealer. Right. So we made a point of, we had to widen the air gap of the inductor in order to handle a 50 BMG. Mm-hmm. Widening the air gap meant we needed more power, because as I was saying before, the wider the air gap, the less power you get. So we had to go from 380 volts to 420 volts. Mm-hmm. We also made more fan speed, because when you're using that much energy, it generates a lot of heat inside the annealer. Yeah, right. And so we need fans to cool that down. So the Mark II has 5 fans internally, which are bigger, more powerful fans than the Mark I. Mm-hmm. And also we put a ceramic insert inside the inductor as a heat shield. So all of those were big improvements on the Mark I. We released the Mark II, I believe it was in late 2018, and it just sold like crazy.
Mm-hmm. Yeah, and for me, it's been like an appliance. Yep. You put the brass in, you do the analyze, and then you just rock and roll with it, Exactly. 1, 2, 3, hundreds, however many I need to do.
We know a lot of guys who just set their kids doing the annealing while they're out doing something else. It's no big deal. But that then led, speaking of actually doing the feeding, Matt also raised the point of that we really needed to automate the process. For those people who had big volumes, doing it by hand can get tiresome. Although you can easily do 300 or 400 an hour by hand, but Matt thought we needed to do some automation. So he consulted with a design company who gave the original idea of the AmpMate, which now known as the AmpMate, which is a terrific piece of robot technology, if you like. Right. It's a neat thing. A lot of guys just like sitting there and watching it, because it's such a cool thing with dropping the cases in. It's got flashing lights. It's got all the whistles and bells.
Right. And you can see through the whole thing.
You can, and Matt deliberately designed it that way so you could see all the working mechanism.
Love it.
We need a Dillon or a Hornady rotary hopper to feed the cases into the AmpMate, but then the AmpMate takes over and feeds the cases and extracts the cases into the annealer. So that was a big step forward for all the guys who are doing big numbers of cases. They get the AmpMate.
Yeah. So then comes the amp press. Let's talk about the motivation for the amp press.
Well, the motivation for the amp press was initially for our own use, to validate a lot of the results that we were getting with the annealing.
Yep.
So what we were trying to show to ourselves was what real effect does annealing have on neck tension. Now, neck tension is a complicated thing, or the seating force is certainly a complicated thing, because there's more than just diameter, if you like, or interference fit, to use an engineering term.
Yep.
There's more than just that going on in order to push a bullet into a case neck. There's also friction. And so you've got to, in order to quantify what you're actually getting with seating force, you've got to take those factors into account. So we did all of this for our own laboratory testing. We wanted to show if we anneal a case and not anneal a case, what's the difference in seating force?
Yes.
And so we did all of that sort of testing, and then we published some of that testing. And people said, wow, that's a neat piece of equipment. You know, can we have one too?
Right.
So that then led to a whole nother lot of product development. I've got to tell you, product development is not a thing to be taken lightly. It takes a long time and it takes a lot of money.
You have a formula in the book, right? Does it take like 3 times as much money and 3 times as long to take it to market?
Yes. When you bring a new product into the market, or developing one, be realistic with yourself. It's going to be expensive and time consuming. The press took, I don't know, a year or more to get to a marketable product. The software is quite complex, but we're now getting a whole lot of guys, the high-end reloaders, are loving the amp press because of the sheer data it gives you. It gives you not only the seating force in graph form, which you can export, you can share it with other people, you can save it, but it also gives you the distance axis on the x-axis, which is down to 1,000th of an inch. So if you haven't trimmed your cases accurately, it's going to tell you. Even if you haven't chamfered uniformly, it's going to tell you. If your bullets are a different length, which, trust me, that does happen.
Yes.
Every bullet out of a box isn't the same length. Well, it'll tell you that too.
And if it's not the same length, the BC won't be the same.
Well, you've got to think so, don't you?
Yeah.
So we're not BC experts, but we believe that it's experimentation that should be done.
It's data that you can get graphically that tells you something's going on here, right? Maybe I should take a look at this.
Exactly.
Love it.
So the press has been, it's proving more and more popular as more people are using it. It's gaining its own momentum. So it's certainly been a worthwhile development for us.
Yeah, and it's also entertaining to see the data and to be able to spot the outliers and quality control.
The funny thing with it, when we first started testing ours, we thought we're pretty good reloaders. We know what we're doing. And we got these graphs that are all over the place.
Yeah.
We thought, how can our reloading be that bad? The press itself mustn't be giving us reliable data. So Matt made a dummy die up, a dummy seating die, spring-loaded.
The test die.
And a test die, and it turned out it was giving dead straight lines every time, repeatable. So it wasn't the press, it was perfect. It was us. Our reloading wasn't good enough. And so what it teaches you, the press teaches you to improve your reloading techniques.
Yeah, we use it, and we just filmed a whole video with Matt on the latest and greatest on the software, so you're going to want to check that out. Let's briefly cover Annealing under the microscope. So this is an entire research series that Annealing Made Perfect has published, and if you're really interested to know about the metallurgy, to know about annealing as a technology, to the theory versus results, all the way from the Mythbusters at the start to proving out everything in the field, correlating what's happening with your analytics to actual results on target. Exactly. It's going to cover all of that from start to finish.
Exactly, the whole series. It started out the first article, and it's in the appendices of the book.
So if you buy the book, you get it all in print form, which is really, really nice for convenience.
It's all on our website as well, but this is a better way to
I think so, yeah.
The first annealing under the microscope, which we did, was in 2017. And it was purely a myth-busting exercise. We found that having discovered what we had discovered in the lab with doing all this processing, and then Matt checking the forums still had it all completely wrong. And so, there was just simple factual errors circulating as common wisdom.
Right.
And so we wrote it as a myth-busting exercise, and in order to be credible, we went to 2 or 3, there was actually 3 consulting laboratories in order to get the data that we needed to publish. One was One did the actual metallurgy in terms of the grain size and the structure and the hardness. Another one did the alloy composition. We gave them multiple different brands of cartridges to see, is the alloy a significant thing, the copper and zinc combination.
Yeah, right.
And that was interesting because we found that most American brass that we tested was around about 68% copper and what are the maths, 30, well, the balance was zinc.
Yeah, yeah.
And then most European ones were 72% copper and the balance zinc, which means that the European ones are slightly softer as an alloy. We found though that it made almost no difference to annealing itself. So that's a question we were getting asked a lot: is does the alloy matter?
Right.
We don't think the alloy matters in terms of annealing result.
So you almost accidentally became an expert in some of these interesting areas.
Yeah, because we put the R&D into it and we paid people.
Right.
We're not saying we knew everything, we paid people who were qualified to know everything.
But you produced these results that are now for free. So if you go to the website, you can download the entire Annealing Under the Microscope series for free, right? You can read it, they're PDFs, it's great. But if you buy the book, you're going to get that. I read this on vacation. I took this to the ocean and I read the entire book, and it was really handy to be able to just thumb through the entire series at the end and look at the graphs, and you can keep it as a reference as well.
Yeah, the first 4 articles in it were all laboratory based. They were what other laboratories could produce, what we were producing in our own laboratory in terms of seating forces, all of that sort of stuff. But then we decided, look, we really need to get some, what does all this matter if it doesn't matter downrange on target?
Right.
So we're not the greatest shooters in the world, we don't claim to be, we enjoy shooting, but we're not competitive. And so we went to some of the best shooters in the world to do testing for us and give us the results of theirs. We went to Lou Murdicker in particular with his magnificent facilities in Palm Springs. He tests for a whole lot of companies, and he's done great testing for us too, which validated a huge amount of what we believed would happen with the benefits of annealing. He validated that. We also had the Strategic Edge guys over in Tennessee do massive amounts of shooting for us with different guns, different ranges, etc., to validate does annealing actually pay off on target downrange. And the very conclusive evidence was yes, it does.
Right. And this is what I like about this story, is that you're essentially able to take an area of shooting sports that's a black art, a misunderstood domain, and then build products and build scientific evidence to help everyone understand what are the things that you should pay attention to and you should do, and then the things that you can kind of ignore or deprioritize, right?
I think that reloading is a very complex process with lots of things that will make a difference downrange. So the idea for every reloader is to standardize everything, to normalize everything and be repeatable. So we can't speak for all the other processes involved with reloading, but we can say that if you anneal your cases, you've eliminated one source of error.
Yes. It's about controlling and minimizing those variables that are going to affect your performance. Well, this is really good stuff. If you want to buy the book, go to the Annealing Made Perfect website. You can buy it directly from there. Alex, it's been a pleasure to talk with you.
Thanks, Gavin.
I'm looking forward to ongoing adventures, exploring some of these problem domains, ongoing discussions, and hopefully we can meet up at our respective home bases at some point as well.
That would be a fantastic thing.
So here's what we'd like to know from you is, what do you think about the whole story of Annealing Made Perfect, and have your results mirrored what we've been talking about? Drop a comment and we'll start a discussion. That concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. If you're interested in custom rifles like what we build here on the channel, or gunsmithing services, you're going to want to go to rifles.ultimatereloader.com and get on the wait list. If you're interested in becoming a professional gunsmith, check out the Sonoran Desert Institute. They've got a degree program, they've got a certificate program, and you can study from home. Learn more at sdi.edu. Thanks again for watching.